Okay, now in one of the earlier videos we saw what a C is. I put the C instead of the P. That means we don't protect these three. I don't want them ranked. I just want to know how many combinations of three. So don't circle that and write protect, okay? So you're going to put the 12. Those are how many are relevant, okay? So you have 15 people. You're picking groups of three. How many ways can you make a group of three? You don't have to like pick three people and re-rank them, okay? So we don't protect crap here, okay? So what we do is we go 15, and then we don't protect them, so we put the other ones on bottom, okay? Now, we number the 15, and then the 12s cancel, but since these three are not protected, we also number those down, okay? So put 15 times 14 times 13 divided by 3 times 2 times 1, 455. Now, you don't put orders, okay, here. Combinations have nothing to do with orders. You put combos of this number here, 3, okay, because you're not going to protect it, but that's how many combinations of 3. Okay, this one, you'd have 12 you wouldn't group, because if I have 16 people in class, I want a group of 4, just pick one group of 4. Well, there's 12 people not in the group, okay? So that's why I'm getting the 12. We don't protect the 4, though, because I don't have to re-rank the 4. First, second, third, fourth has nothing to do with this. So I ain't protecting nothing here, so they both go here. So you number the 16 down. So you're at 12, and the 12s cancel, and that becomes 4, 3, 2, 1, okay? Close it, and then divide by 4, 3, 2, 1. 1,820, okay? You don't write orders, you write combos of 4. Okay, there'd be 7 not in the group. You have 10 people. You want to figure out how many ways you can make out a group of 3. Okay, so 7 would be out of the group. Okay. Remember, just a 10 finds complete orders, but ordering has nothing to do with it, so I don't protect anything. Okay, so I put them both down there. 10 times 9 times 8 times 7. Those cancel, and then 3 by 2 by 1. That's going to be 720 divided by 6, because that would be 90 times 8 is 720. If you can't do that in your head, you need to go with this. Okay. No, I'm not saying that's bad that you can't do it in your head. That didn't mean to insult. Okay, 3 times 2 times 1 you can do in your head, but yeah, the top maybe not. Okay, so 120 combos of 3. So when I'm using the permutation, I write the big P, I write down orders and then first through whatever. Okay, here I just write combos of 3. Okay, and here we go. During the basketball season, a school plays 12 home games. A teacher wants to attend 3 of these games. How many different combinations of games can you attend? So 12, okay, is how many I have, question mark. I'm not going to all of them, though. I'm going to 3, so there'd be 9 I wouldn't go to. Now, we don't protect the 3 because I don't see the words first, F-I-R-S-T, second, S-E-C-O-N-D, third, T-H-I-R-D. Those are nowhere to be found. So that's not protected, so I go to the C. So I take 12 factorial and divide by the 9 and the 3. So 12 times 11 times 10 times 9, and the 9s cancel. And then 3 by 2 by 1. Divided by 3 by 2 by 1. Okay, 220 Now again, how do you label this? Not orders, combos of 3. Okay, the cage fun. I actually made a video on this a while back. That's fine. We'll just go over it again. The more we can hammer it home, the better. Okay, Hermson has 25 people in his math class. He picks 4 of his students to enter a cage fighting free-for-all. How many combinations of students can he pick? Okay, so 25, and we're not ranking them, but we are picking not all of them, 4, and there'd be 21 that we wouldn't pick. Okay, now I don't see words first, second, third, fourth, so I use the C and I don't protect them, okay? Remember, 25 factorial finds complete orders out of 25 people, but I don't want to find orders at all, okay? So I don't protect them, and these are both going on the bottom. That always goes on bottom because those are like the irrelevant people, okay? They're both going on bottom. So 25 times 24 times 23 times 22 times 21. And our 21s cancel. And then I number the 4, 3, 2, 1. Okay. Divided by 4 by 3 by 2 by 1. 12,650 combinations, I just don't feel like writing the word, of 4. Okay, and then there's a card problem. A standard deck has 52 cards. How many possible 5-card hands can you be dealt? Okay. Now you're going to use this number here for the next part of the video of the packet. Okay, so again, 52. You're not going to have all 52. You're just going to have 5. Okay, so question mark. Now obviously I don't see first, second, third, fourth, fifth, so I don't protect anything. Okay, and that's my C. So on combinations we put them both. If I don't see the protect, that means it goes on the bottom. 52 times 51 times 50 times 49 times 48 times 47. And that's 5 times 4 times 3 times 2 times 1. Okay, so 52 times 51 times 50 times 49 times 48. Close it. Divided by... Oops. 5, 4, 3, 2, 1. Okay. Now, you need to remember this number for the next part of the video. That's how many different hands you can be dealt. Okay. Combos of 5. Pause the video, please, and do 1, 2, 3, skip 4, go do 5 and 6. 4 deserves its own special place, okay? Okay, hopefully those went well. Now here's how to do number 4. This is a card sheet for those of you not card players. You have red cards, 26 of them, 26 black. We're not counting jokers, okay? Hearts and diamonds are your red suits. There's 13 of each suit. Spades and clubs, 13 of each suit. Some of you card players are like, duh, you don't have to tell me that. Well, I've seen a lot of people not know how to play cards, okay? Now, up here, you see that. That's how many combinations of 5 cards you can be dealt. You need to copy that number here, just up in the corner. 2,598,960. Okay? Remember that. You're going to use that for the second part. This and this are 2 separate problems. Okay? How many ways is it possible to draw 5 hearts? And it says there's 13 hearts in the deck, but you can see that right there. cross that out. I don't even want to see that there. You see one number, okay? 5. So you make 1C, and you put how many? You're not going to use 52, because out of all the hearts, how many do you have to pick from? 13. And you want to draw 5, so there'd be 8 you wouldn't draw. So first, fifth, second, third has nothing to do with this problem, so we don't protect that. And we go 13 divided by 8 and 5. Stop the countdown at 8. Times 12 times 11 times 10 times 9 times 8 divided by the 8. And then the 5 by the 4 by the 3 by the 2 by the 1. Wrap the parentheses up and calculate that. Oops, you got to get the 9 in there. Times 9. $1,287, okay? Combos of 5. Circle that. Now here's how you find probability. It's very easy, okay? You want to draw 5 hearts. This one is a flush, okay? Put your 1,287 in the numerator. Now, how many combinations of just any 5 cards can you be dealt? We just found that, okay? That's why we're going to keep using that number. Now, here's how you find the probability. You divide, and it's always some decimal. Then you're going to multiply that by 100, okay? You have a 0.05% chance of this happening. Yeah, not great odds, but there's a chance. You divide and times 100, okay? That second part's easy. The hard work's the first part. How many ways are possible to draw 4 kings and 1 non-king? Now, up here you just had 5 hearts. But here you got 2 categories of cards, the kings and the non-kings, okay? So it says there's 4 kings in a deck and 48 non-kings in a deck. When you have 2 categories like this, up here you just had 1 category. You write C times C, okay? You actually have 2 C's to find. So how many kings do I have to draw from in the deck? 1, 2, 3, 4. How many do I want to draw in the problem? 4, okay? Well, that leaves you with 0 here, you know, because 4 minus 4 is 0. Then we know that that's 1, okay? There's only one way you can draw 4 kings. But the non-kings, there's a lot of different ways you can draw those, okay? Now, if I have 4 kings in a deck of 52 cards, how many of these are not kings? Well, probably 48. That's how many there are out there, and I want to pick one of them. So that'd be 47 that I wouldn't get to pick. Okay. All right, so let's calculate this. And you don't protect anything, not on a C problem. 47 and 1. Well, this ain't hard. 48. Times 47. The 47s cancel, and that gives me 1. So 48 divided by 1 is 48. Then multiply them. Remember, if you get 0, don't even waste your time. It's 1. Okay? So that's 48 combos. Okay? You don't need to label below that. Okay? Because it's 2 C's, don't worry about the label. Now, the probability of it happening, getting 4 kings, well, there's 48 ways it could happen, divided by the total 5-card possibilities. 2, 5, 9, 8, 9, 60. You're always going to use that in your denominator and probability of getting a specific hand of cards. 48 divided by 2, 5, 9, 8, 9, 6, 0 times 100. Whoa, this is really low. 0.00, and just round that 1 up to a 2. and that's your percent odds that you're going to be dealt 5 kings on the spot. Now, obviously in poker you get wild cards that can count as kings, but I'm not, maybe Mr. Larson does because this is more up his alley, okay? There's probably a way, I'm sure there is, to find it, but. How many ways is it possible to draw 2 kings and 3 non-kings? There's 4 kings in a deck, 48 non-kings, okay? So again, you have 2 categories that you're going to be drawing, a pair, okay? Now there's a lot more ways to get just a pair of kings than there is 4. So I need a product of 2 C's. Now we got 4 kings in the deck, and I want to draw 2. So there would be 2 I wouldn't draw. We have 48 non-kings in the deck. Now I'm going to be dealt 3 of those, so there's 45 I wouldn't be drawn, okay? So I need to find each one of these and multiply, okay? So nothing's protected because first, second, third, had nothing to do with the problem. So we protect nothing. That means I take that, divide by both of these. So 4 times 3, stop at 2. Those cancel, but then you have your other 2. You should do that in your head. It's 12 divided by 2, which is 6. So I'll put a 6 there. Okay, I kind of like putting that on top. It's cool. Okay, all right, 48. And again, we divide by both of the remaining because nothing's protected. If it's protected, we don't want to divide by it. That's a totally different problem. 48 times 47 times 46 times 45. 45, see ya. 3 times 2 times 1. Okay. So I take 48 times 47 times 46, close it, divided by the product of 3, 2, and 1. 17,296. Now you want to multiply these two together. Okay. 103,776. Okay, combos, and since it's 2 different, groups, just leave it as combos. Now to find the probability of you getting dealt 2 kings, you take all the ways you get the combinations you can get 2 kings and divide by that. I've lost it. 2,598,960. Okay, so divide. And then multiply by 100. So that's a little higher. I mean, it's a 3.99% chance. Okay. I guess if you put 4, it wouldn't be the end of the world. Okay. It's higher than some of these others. Some of these others don't even make it into a full percent. Okay. I don't want to do this one. Okay. So again, I'll kind of talk about how to set up 4. So you got 3 jacks, 2 non-jacks. Okay, so you'd set up 2 C's. Now you got 4 jacks in the deck, 3 to pick, 1 you wouldn't. Times another C, 48 non-jacks to pick from in the deck, 2 you'd pick, 46 you wouldn't. And then you do your C calculations, multiply the 2, and there's that probability.